Morning, everybody. Okay, this is a video recorded yesterday. Okay, so I started off there with the model inside Inventor, and you'll notice this has been modelled as a surface model. There's a couple of mounts that have been created as solid models there, and the main body of this exhaust is created as a surface. So if I go on, from these environments on the ribbon here, you've got the link straight into Nastran, so you can see it's built into Inventor. And what we're doing now is assigning properties to the geometry. You've got a choice of single lines, shells, or solids. So because we've modelled this as a surface, we're going to apply a shell element to it, and there we're specifying the thickness. The materials we can pull through from Inventor. There's also a library available within Nastran of other materials if you need stuff that's not inside Inventor. And here you can see that it's pulling through the physical properties in terms of mass, elastic modulus, and the yield limit there. Okay, so once the physical properties have been assigned to the parts, we can associate the geometry that's going to be using that particular value. So then we can go and click on the model to assign those values. Now once this data has been acquired, we can use this duplicate function and use the same settings of different geometry within the model. So here we're just going to clear that particular set, and then we can reuse that data. It's useful to name them, rename the different groups, because then when we want to vary the analysis for later on, we can just select that particular group and then make the edits to it. So here within Inventor, just by hovering over the geometry, I'm just waiting there for the options to appear to be able to select that geometry that lies underneath the part that's blocking it effectively. So yeah, so just working through this model, selecting all the parts within it and assigning this value to the geometry. So after the shells have been identified, and notice there's a couple of brackets there which are solid, and part of what we could do in Nastran is mix shell elements and solid elements together. So we've got the tube specified as a section, the exhaust as a section, and then these end caps which act as stiffening members throughout the body. So now this is assigning the element type, so they were choosing a solid element type for the mounting brackets, and then it's just a question of clicking on the parts within the model. Okay, now we need to fix it in space. So here, I'll just pause that a second. So in this dialog box, you've got the option to control which degrees of freedom you want. So when it's fixed, it will automatically lock everything down. If you want something that's going to be rotating, then it will just stop translation in the X, Y, and Z directions and allow it to rotate. If you have things that are sliding in a particular, then you can use these functions. So you've got some shortcut keys effectively to allow the degrees of freedom to be applied. Right. So when it comes to the mesh data, you can specify the size that you want. So when it comes to convergency studies, you can go back to here, this setting, and put in different mesh sizes to rerun the analysis and checking that you're getting convergence between different models. Now, because we have a mixture of solid elements and shell elements, we can use this weld feature, effectively referred to there as offset bonding, so we can lock the solid element to the shell element. So this offset bonding, that's something that you don't see in Inventor. It's something that's an added feature that you get within Nastran. So the workflow is fairly similar in terms of associating the geometry to what we saw when we were specifying the shell element. Right, so as the analysis runs, you get a scrolling screen here that gives you feedback, and this allows you to look at convergency rates. Now this is a video pre-recording, so it didn't actually do it that quickly in real time. It depends on your hardware that's in use. So now you can see the nodes that have been created in terms of the natural frequency from this vibration study. And from the displays, we can create an animation which will give you an idea of how this part responds when it's being shaken. Now the display here is being amplified by 10, but it gives you it gives you a visual feedback as to how it's how it responds. So there you can see the percentage increase in movement. You can toggle it down to actual movement if you want to see what the real world response is. So in addition to a graphical data feedback, you can also extract plots. So here I'm going to create a graph of the movement in the X, Y, and Z directions, and that will be plotted against the frequency that's been studied. So clearly that peaks out about moving over 20 millimeters. In addition to the animation displays, you can also create sectional views, and you can look inside the model and see what the values are as sections. That's something that you can't do in Inventor as well. Okay, so this is the option. Once I've got this model set up, I can copy the analysis, and that's all the values of it that I've just put in. I can reuse them effectively, and I can make changes to them. So in this instance, I want to change the thickness of various parts of that model and rerun the analysis. So because I've subdivided those into sections beforehand, it's just a question of going and editing each value now. So there, for the end caps, I can go and make them from a thicker material. So this is, I'm coming out of Nastran now, I'm back in Inventor. I'm going to these surface mounts, just changing the thickness on these from the previous thickness. So I'm toggling from Nastran into Inventor, make the modification, then I can go back into Nastran. So from the ribbon, just pick the Nastran interface, remesh my model. And this is real time further meshing. And then rerunning the analysis. So again, once this is completed, I extract the values from the graph, as we just saw in the previous exercise, and we can see how the thickening those different parts has affected the natural frequencies of this exhaust. Because for a new product, trying to analyse the frequency response is going to be time consuming and expensive when you're trying to use road data. So this is just comparing the two results. So using the shell element is one of the advantages of being able to create a surface body. The shell element will be used less quadrilaterals and reduce the number of nodes that are needed. So that will help speed up the analysis further down the line. And being able to use the welded contacts to link the solid elements and the shell elements together. It's just a way of just generally increasing the speed at which models can be put together and analysed. There you can see the changes that those thicknesses of materials have made to the study, and there's less movement, which would be expected with them being thicker. But also, if there's particular frequencies that can cause a problem, they can be seen through this study. So here, from the analysis, we can see the responses to particular frequencies. So the next stage from here is looking at those frequencies and seeing if there's going to have a problem with fatigue in the parts that are suffering under those particular loadings. Normal modes is a natural frequency analysis. Buckling for frameworks, non-linear for if you're pushing parts beyond the yield point, and then you've also got the fatigue analysis, which I've got another video of, and then you've also got heat transfer options as well. So it's just, you can see the options there on the drop down, and the workflow is reasonably similar in that you create subcases and loads for each of the different analyses, and you enter your values into there as you need for the required analysis. Right. So once I've done this study here and found the frequencies, I then need to do the fatigue analysis. So this is using the fatigue analysis, and it's just going through here. You can see these subcases and entering the values that are needed. So there's options of what studies you need, what are the values to put in for the various subcases, and then putting in the range that's needed for the frequencies. And also you'll need to know what the SN data is for the material that you're going to be using, and that's entered as part of the fatigue data. So we'll just come to that in a second. So here we go. So this is right-click driven. Okay, so that's all the data needed for the fatigue analysis. We can then run the analysis. Again, this is edited, and then it's just a question of going through the results, picking on the output required, and seeing what damage can be created under those load conditions. And here, under this, the specify max and min, we can see that there's no particular damage being created under these conditions for this particular part. So that's obviously fatigue study is something that's very difficult to carry out in the real world. So it's something that will help speed things up and hopefully reduce costs. Okay, so that's the end of the fatigue. That's the natural frequencies for this particular model.
Fair enough.
And that's the study complete.
Thanks very much for that, Andrew. Thanks very much. Cheers for that. One question I've got immediately, I know there have been some questions raised which we'll come to in a minute, but just on that note, you know, you skipped the analysis bit for the benefit of the webinar.
Mm-hmm.
What sort of system requirements would you sort of suggest, and what would we need to look at specifically in order to drive this if it like fluidly?
Better the PC, the quicker it will respond, but generally an inventor capable PC will Nastran. It is quite memory and disk space intensive, so once it is calculating sort of hundreds of thousands of points on the meshes and the nodes, and these analysis needs saving. So if it is a large model, you are going to be creating a lot of data, so the bigger the disk drive you've got might help.
Right, okay. That's caching. Yeah, okay. No, thanks for that. I don't know if somebody else has asked that. We'll come to it, and I apologise if I've read out somebody's question already. Right, so turn back to the slides just now. Not long to go, I promise you. We'll just have a look at how Quadra can help. Obviously, as you've seen, we have Andrew and the team here at Quadra, and as you probably appreciate, like all software, you get the best out of it with the right foundations in place. So this is where the expertise of the guys here comes in. If you looking at this, if you find that Nastran might have a part to play in the workflow, it certainly has impact across most, if not all, sectors. So it will affect you in some way, shape, or form. And we'd love to get involved to help you realise that potential. Typical scenario: those who've dealt with Quadra before from a consultancy angle know that we need to really ideally sit in front of you and find out which sim areas Nastran has that will have a fit, and see what requirement needs to be, what your requirements are and what objectives need to be achieved. In terms of the actual offerings, we've got bespoke training courses. You can't really run a scheduled training course on Nastran because it's that vast. You typically might not need all the bells and whistles at all the time, so we'd suggest a bespoke training on the areas that you need to focus on. And as part of the Autodesk developer network generally, we're in tune with sort of regular updates, best practice, and so on, which we can help you with as we go on as a partnership on a Nastran project. So let's have a look at some of the questions that have been raised so far. I've raised the technical specifications one, so somebody's jumped in already, apologies. We've got a question here. Andrew, first off, what's the difference between, because we've talked about Nastran in CAD, and there's also Autodesk Nastran on its own. Is there any notable differences between the two without the in-CAD?
The benefit that you have of in-CAD, like you can see from my example there, if you want to make a modification to the geometry, you can switch out of Nastran straight into Inventor, make the modification.
Yeah.
And then so you can work between the two environments smoothly. Nastran on its own is you import the geometry into it and then you run the analysis.
Right. Okay. And just as well, in terms of the licensing, because I mentioned before in the presentation, everyone, that Nastran in CAD is a network license only, if you will, so it can be shared between multiple seats. But do you know at what point it borrows the license from the server? Because you've got the Nastran tab in there. When you click on that tab and you bring the environment, it then takes that license from the server.
I typically would keep it until the inventor's shut down.
Right.
So if you close it and then it gets returned to the...
Right, so you borrow it and it takes a license from Nastran, and then when you close Inventor, it then sends it back to the server. Yeah. Right, okay. That's useful to know. Version requirements on Inventor. Sorry, I'll read the question. What are the version requirements on Inventor to be able to use Nastran in CAD?
Right, it'll be year for year. So if you have 2015 Inventor, you'll need 2015 Nastran. If you go for 2016 Inventor, you'll need 2016 Nastran.
Right, so the two need to be aligned. The two versions need to be aligned up. Right, okay, just for that. Question here looking through, is there a 32-bit available for download?
No, it's all 64-bit.
It's all 64-bit. Okay, this is not really releasing 32-bit then. There's a couple more questions on here, but I think they're sort of relating directly to individual workflows. They're getting a little bit technical other than that, I think. Having a look at this, what we'll do for those questions, appreciating that some of these look like they're going to be quite long answers that might not be relevant to everybody, so we'll respond to those later on. At any point, by the way, if you want any of these slides or information from Andrew as to how Nastran could affect sort of your products directly, indirectly, get in touch, send me an email, put our details on the display for the time being. That's pretty much it, I think. The vibration testing there are test cases for any manner of areas for simulation that we can look through and discuss with you. So get in touch, give us a ring, send us an email. We're happy to pick things up. Thanks for joining us today. Hope you found it insightful, and we will hopefully speak to you soon. Cheers for now.
Yeah, thank you.